Welcome to our video lecture on Introduction to Atomic Theory. This is going to be super short and easy, my friends. So our objectives for today, we are going to define the words hypothesis, theory, and law as they relate to science. We're going to talk about how our understanding of atomic structure, how atoms are shaped, how that's based on some theories that have changed over time. So our understanding of atoms have changed over time. We're going to talk about this guy, Dmitri Mendeleev, just a little bit, and how he developed the format of the periodic table that we still use today. And then we're going to wrap up with why elements in the same group on the periodic table have similar chemical properties. We're going to start with a little bit of vocabulary here. So, hypothesis is a testable prediction. So in science, we make some observations of the world, and then we make a prediction based on those observations, and then we try to test that prediction with an experiment. That prediction is a hypothesis. Once we carry out a lot of investigations with a lot of hypotheses and we have a lot of data that supports the same kind of idea, the same kind of explanation, that becomes a theory. So a theory is science's best explanation for how or why some amazing phenomena happens. It's based on lots and lots and lots of investigations. But these theories can change over time. Theories can change over time when we gain new evidence. New evidence is going to lead to changing our theory to fit the evidence that we have. So theories and laws are a little bit different. Hypotheses can grow together, lots of hypotheses together can build up a theory. Scientific laws are kind of separate. So these are more of mathematical constants. They're like the what, not the how or the why, just the what. An example of a scientific law is the law of gravity. Here on Earth, things accelerate at 9.8 meters per second. This is the what. This is what speed do things accelerate at. It's not why does gravity exist. It's not how does gravity make things move. It's just this is how fast they move. And so scientific laws tend to be a little bit more mathematical, and then those theories are more of like our explanations for why, like that Big Bang theory. How and why did the universe form the way it did? All right, so development of atomic theory has changed a lot over time. We used to think of like atoms as being like marbles, and then we had this pudding idea, and then we thought maybe it was pudding with a nucleus, and then we made it more like planets revolving around a nucleus, and now we've got this quantum wave function orbital dealio. That's pretty cool. We've changed our idea of what atoms are shaped like a lot over time. These are some of the people, just some of the people who have contributed to our understanding of what atoms are. We're going to research in class lots more. So I'm going to back up a little bit and talk a little bit more about the periodic table, and then we will call it a day. So this periodic table thing has been developed by lots of different people. Dobereiner was one of the first people to try to group elements by similar properties. He noticed that things came in thirds, so he had some sodium and potassium, and he was like, these guys are pretty similar, lithium, sodium, and potassium, and they came in triplets. And so he thought things came in thirds, but then we learned more elements. And so this other guy, he was like, maybe they're like this helical cylinder of elements where they spiral around in properties. And then this other guy was like, but wait, they come in groups of 8, not 3s. And he liked music, and so things were in octaves like in music. And then Mendeleev was like, but wait, we learned about more elements. And so Mendeleev decided to group elements by increasing atomic mass. So hydrogen is first because it was the least massive. Lithium was next because it was second massive, and then he would move over to a new column, beryllium and boron and carbon and then he moved over to another column, and these got heavier and heavier, and then he started another column and they got heavier and heavier. Our modern periodic table is based on this format of increasing atomic mass, and then also having groupings according to similar properties. So if we look at going across these rows, these elements have similar chemical properties. Fluorine, chlorine, bromine, iodine, they have similar chemical properties. And so we went increasing mass this way similar properties going this way, and that is the format that we still use today. And the magic of this is that we can predict properties of elements based on their location in the periodic table. We can predict the properties of elements based on their placement in the periodic table. So our modern periodic table looks like this. I can find this element and I'm going to say, you know what, this guy, because it's here, I know that it's going to have similar chemical properties to all the elements in the column. I know it's going to have a smaller mass than this guy, but it's going to have a bigger mass than this guy. Modern periodic table continues to change. We actually have added a bunch of elements here, not that we necessarily discovered, but more that we created. So we mash atoms together in these super cool colliders and make new elements. And so it's more about synthesizing new elements than really discovering anything new. But still, that periodic table can help us predict the properties of elements based on their position in the periodic table. Because elements in the same group, and groups are going up and down, elements in the same group have similar chemical properties. And the reason is this. Notice at the top of every column, we have some numbers. There's a number 1, and then there's a number 1A. I want you to focus on those numbers next to the A's. 1A, 2A, we're going to skip over here, 3A, 4A, 5A, 6A, 7A, 8A. So these numbers next to the A's tell us the number of valence electrons. Valence electrons are the electrons in the outermost energy level of the atom. All of the guys in this column have 3 valence electrons, 3 electrons in the outermost energy level, the outermost electron shell, whatever you want to call those rings, those levels. These guys all have 4 electrons in that outermost ring or shell or level. And they have 5 and they have 6. And over here they have 2 and they have 1. And because they have the same number of valence electrons, they're going to behave similarly in terms of their chemical properties. And my friends, we are already done with our video lecture for today. Did we define hypothesis, theory, and law? Yes, we did. Do we know that our understanding of atomic structure has changed over time? Yes. We're going to talk a lot more about those people who contributed to the changing understanding when we do our research projects in class this week. Do we know that Dmitry Mendeleev developed the format of the periodic table that we still use today? Yes. Going by increasing mass, or now it's actually the increasing proton number, increasing atomic number, and also by chemical properties. And then those chemical properties are similar amongst elements in the same group on the periodic table because they have the same number of valence electrons. Good work today, my friends. See you in class.